Hi, everyone. Thanks for making it in here after filling your bellies. I appreciate you coming by. My name's Casey Lang. I work at Daily Burn, where I spend most of my time trying to improve the tools and processes that our developers use every day. My most recent project was migrating our existing infrastructure from a private host onto the cloud. In our case, we went with Google Cloud Platform, but most of this talk is going to be transferable to whatever provider you end up using. Before I go further, I want to acknowledge my two teammates, Will and Connor. Without them, this project never would have happened. They're really the brains behind this operation. I'm just up here because I happen to be the best looking, so. If you're like me and you're more dev than ops, there's a lot to learn in this space. For any infrastructure project, the more you know going in, the better you're going to be halfway through your project. There's a ton of great ideas out there. One of the really best ones that really helped me along was the 12-factor app. If you haven't checked this out, I suggest it. It covers everything from version control to how your application can be structured, all the way down to logging and everything in between. It's a really great starting point. As I was putting together this presentation, I realized that constantly referencing my company's infrastructure and the things that we did during our migration wasn't going to be very useful. I wouldn't be able to give you the code at the end of it because we need it to run our company. So instead, I put together a demo app. This app isn't nearly as complex as our real-life production environment is, but it covers a lot of the same key points. So in the app that we're going to create today, I have a pair of web servers. I have a load balancer in front of it. I have a caching server. This in case it just happens to be Memcache. I have a Consul cluster, and then I have a database to connect it. And I drew this by hand. That's why it looks so awesome. So let's start by building a few cloud resources in Google. The best way to do this, obviously, is Terraform. Terraform is a tool for codifying and launching infrastructure. It works with a huge range of platforms, and you can always go to the Terraform site and check out the documentation if you haven't already. I have a plan named production. In this file, I'm just declaring what I need for Google to connect initially and just say who I am and where I want to build my things. In this case, I've declared the project name, the region, and my credentials. So since I have those variables, I need to define them before I can actually run Terraform and build anything. So in this case, I've created a variables file and put some placeholders with some defaults and some text to describe it when you're filling it in. Here, I need to overwrite some of these variables. For me, a good practice has been creating a terraform.tfvars.example file and checking that into my repository and filling it with just sample dummy data so that when another dev comes in and pulls down this project, they can create a terraform.tfvars file, which I've ignored in Git, and they can fill it with their information for whatever they need, which saves them from having to enter in all of the information every time they run Terraform. Obviously, once you've automated this process, this step goes away, but this is helpful when you're in the initial testing and building phase. So now let's do something useful. Here, I've requested a Google Compute resource, and I'm going to name this Consul server. There's nothing about this resource yet that actually makes it a Consul server. It's just I've decided to name it that way. I've told it to just use a Google-provided base image, and I've given it a count variable, which is the way that I can tell it to build 1, 2, 3, or X many instances of this resource. So it creates that resource, and it also creates a firewall rule so that things within my network can connect to this instance and interact with Consul. So in the same way that the production plan needs variables, our Consul module, which we just created, also needs variables. You'll notice that I've set the Consul count to a default of 3. This is because Consul needs quorum to maintain a healthy amount in order to maintain the data that it shares with itself. If you're ever down to just one Consul server, Consul will continue to run, but it's pretty risky. And if you lose that last server, you're kind of out of luck. The Consul docs recommend at least 3 servers to stay sane, up to 5, and obviously you can add as many as you want. Finally, I know that eventually I'm going to want to know where these Consul servers live. So I'll create an output file for my Consul module and have it place the Consul IP in the output. Now that I have my module ready, I need to reference it back in my production plan. That's as simple as adding a reference to the Consul module, telling Terraform where it can find that module. In my case, it happens to be local to my system, but this could also come from somewhere like Git. Now let's build the resources. I change into the Terraform production directory. I call Terraform Git. What this does is, since I'm using a module, I need to pull down the code and the configuration for those resources so that Terraform can actually build them. I call Terraform apply, which goes in and tries to see what resources currently exist. And in this case, since there's nothing, it knows that it needs to create everything. And at the end of it, we can see that my plan was successfully applied. I have 4 resources added, so that's the firewall rule and the 3 Consul instances. And in my outputs, I see that I have all 3 of my Consul server IPs listed for me, so I know that they were created and I have the location to access them. So if I wanted to SSH into one of these boxes right now, I could, but so far they're just generic CentOS boxes. They exist and I named them Consul servers, but they don't actually have Consul and they don't really do anything. So to get them to that next step, I'll bring in a tool called Ansible. Ansible is a configuration management tool. If you have a configuration management tool that you prefer, use that. If, for me, that tool happened to be Ansible. If you don't have a configuration management tool of choice yet, check out this book from Vloudhouse called Taste Test. It goes over a very basic comparison of Puppet, SaltStack, Chef, and Ansible, and it covers a little bit of Docker as well. It's a really good start to understanding what tools exist in this space and the differences between them to help you make a better decision. So back into Ansible, I'll start by creating a play specifically for configuring Consul. There's a few house cleaning roles that get called first that I actually didn't write myself. Ansible has Ansible Galaxy, which are essentially modules that are created in open source that I can pull down and not do any work, which is better for me. Before I go into the final role, I want to talk about 2 key points in this playbook. The first is I've declared a hosts variable here, a host tag. And you see that I've referenced tag _ Consul server. Previously, when I created my Consul instances, I added a tag there that just said Consul server. Now that I'm in Ansible, Ansible knows that it can reference all of the Consul module, or all of the Consul instances by referencing this specific tag. In the future, when we have additional plays, we'll use a different tag, and they know not to run on instances that they're not associated with. The second thing I want to point out here is the serial to line. So as I mentioned before, with Consul, you need to maintain quorum. This was a really fun bug that not a bug, but it was us screwing up that we had to learn in the beginning, where if you take out your entire Consul server cluster, you lose everything, and it's kind of difficult to get everything back up and running. A quick and easy fix for this was to tell Ansible, don't run everything in parallel. Don't manipulate all 3 servers at the same time. Instead, only do 2, and then do the final one later on. So this tells Ansible, limit yourself. If I had 5, 2 is probably still OK, but I just don't want to run everything all at once. Now into the Consul role itself. The first thing I do is I download Consul and I actually install it onto the system. I create some upstart scripts so that I can get Consul to join and started properly, which I'll cover those scripts in a second. My role also installs DNS mask so that I can query Consul through DNS and find out things like where is a particular service located. And my role is also capable of registering services so that when I have a new service like Memcache be created, I can tell the role, this is the service check, this is where this service lives, please remember it. So there's two of Upstart scripts that I want to take a look at. The first is Consul join. If you've never used Ansible before, the configuration scripts have a templating language associated with them, where I can pass in variables that I get from anywhere, either by gathering facts or by passing them in on the command execution, and replace that in the template on the remote host. So in this case, I'm telling Consul when it runs the join command to use the associated server IP addresses that I've grabbed from Terraform previously. Next is the Consul script. In this case, I'm starting the Consul agent with a few standard items like the data directory. I'm also selectively including the server and bootstrap flag. So in the cases where the instance that I'm setting up is a Consul server, I want to include those flags. If it's not, then I need to keep them out. Since in this case, I do want to configure these instances as Consul servers, I'll create a group bars file for this tag and overwrite the default value for that role. So I'm telling it, yes, this is a Consul server, please configure it as such. So I'd like to jump into the Ansible directory and run the playbook, but at this point, I don't have an inventories file. The inventory file in Ansible is how it knows where and what things to work on. In my case, since my inventory exists in GCP, there's a handy dynamic inventory plugin that I can use specifically for GCP, where it'll go out, find all of my instances, all of my resources, and allow Ansible to use that as its inventory. If you need more information about that, there's a useful doc on the Ansible website. So now I can run my play. I cd into the Ansible directory. I run a pretty long command, and you can see here that I'm including the IP from my previous Terraform output. So this is going to go into that variable that I showed earlier and tell the Consul join script what instances to actually attempt to join to. Ansible then goes through the process of configuring Consul. And you can see here that it's starting with server 0 and server 1, even though we have 3 servers. That's because we declared serial 2 previously, so it knows only to interact with 2 at a time. It goes through a few steps. Since this is a new instance, everything is changing because there's not anything on the box yet. And eventually we get to server 2, and it gets manipulated as well. And we come to the end. Ansible tells us how long everything is taken to complete. It tells us how many tasks were actually ran, what things were skipped, and if anything failed, it would tell us at this point. So now I can log into these servers. I just SSH in using the Google Cloud command line tool. I can run Consul members, and I can see that I have an active cluster. At the moment, this cluster is only a cluster of 3 Consul server modules, or Consul server instances, so they're not terribly beneficial, but I at least know that Consul's up and running and communicating with each other. The pattern that I've used at this point is going to be repeated for nearly every other resource that we create. We start with a Terraform module, we then go into an Ansible playbook, we run everything, and magic happens. So before I go on, I want to make my life a little easier. I'm already tired of CDing into directories and remembering what command to use and what flags to pass with each command. So to make things simpler, I've made a very basic Makefile. Now, you can use whatever script you want. You can use a full build automation system. You can use Ruby, Make. You can write just a generic shell script. For me, a Makefile was simple enough and verbose enough that I didn't have to remember these commands, and I could manipulate it and make my life a whole lot easier. So on to the next component, which is memcache. We start the same way. We create a memcache Terraform module. We define a few resources that it needs to run, such as the firewall rule and the compute instance. I add it to my production plan in the same way that I added the Consul resource. And I can create a configuration play for memcache in Ansible. The first few roles are the same. The memcached role here actually came from Ansible Galaxy, so to get memcache installed and running, I didn't actually have to write any code. I just downloaded someone else's, and it works just fine. And then we call the Consul command again. So since my Consul role defaults to agent mode or non-server mode, I don't have to overwrite the Consul server variable like I did in my previous play. Instead, all I do here is tell Consul what service I want to register and declare as memcache. I'm telling it what port it can be found on and what script to run to ensure the health of this service. So I run one of the commands from my Makefile, which is make create. In my case, make create has entered into the Terraform production plan directory. It's ran Terraform Git for me to make sure that I have the most up-to-date version of my Terraform modules. It's called Terraform apply. It's waited for that process to complete. And then it's called the Consul provisioner. And finally, it's called the Ansible provisioner. So instead of me having to remember all those commands, it's sort of a poor man's pipeline for me to just call one command and finish everything all at once. Now, in this case, I had some resources already existing. I had all of those Consul instances already created. So Terraform's smart enough to go back and say, well, you've only added one new thing. In this case, it happens to be the memcache instance. So it's not going to bother with creating everything else as well. And Ansible can do the same thing. The plays still run, but because they've already been completed and Ansible knows that, it can tell me that while all 22 tasks are okay, nothing's actually changed. They've all been skipped. So it just gives me that extra layer of assurance that I know everything is the way that I want it to be. And finally, it gets into memcache, where a lot of changes happen, because obviously this is a brand new instance, and things need to be updated. Then we finish. So if I jump into my memcache instance and I run Consul members again, I can see that now memcache is associated with my Consul cluster as well. I can also query for DNS with this service definition of memcache, and it'll give me back the response with the proper IP for that particular instance. Now, nothing is yet using this, but it's at least connected, and I know that Consul will have that information available when someone needs it. So the next component in my list is a Rails app. This one is a bit complicated since it requires additional resources like a load balancer and a database. It also needs to be configured to do things like installing Ruby, building Ruby, and installing all the gems. To start, I have a default Rails installation. If any of you have ever built a Ruby app before, you know that the most difficult part is coming up with a good name. Everything else is simple. So for my case, I picked the famous Dutch word wasbier, which, is anyone Dutch? Is that how you say that? So it's a raccoon, I think. But it also came with a cool picture, and it had beer in the name, so I figured it was a pretty good name, all things considered. So we have a washing beer bear. After I could finish the hardest part, everything else is easy. In this case, I'm going to do more of the same. I'm going to have a Terraform module. I'm going to have an Ansible playbook. But it's going to be a lot more of the same. Particularly, let's look at the Terraform module. So I have my compute instance, which we've seen at this point. And we have a count associated with it, a name, and a type. Most of the work in this module is associated with setting up the load balancer. To help understand setting up the load balancer, go check out these docs, because it's fairly complicated for beginners, and those docs from Google do a much better job of explaining how everything needs to be set up than I ever could. But essentially, we're going to have a front-end service, a front-end load balancer that we declare back-end services against. It has its own system of health checks to make sure that those back-end services exist and are healthy, and it brings things in and out of the load balancer as appropriate. But read the docs, they do better. So now we have our play for the Rails app. This play does the same housekeeping processes as before, but then it goes into setting up additional dependencies that are required specifically for Rails. So we set up the project dependencies by installing all of the necessary projects. It then clones the project into a particular folder. It installs all of the gems using the bundle module. The bundle module is new as to version 2 of Ansible. Before, you had to do a lot of crazy things with changing the owner or changing the user that you ran this bundle command as. Using this module has made things much simpler. It sets up a health check in the Rails app so all of my services know where to look at to make sure that everything's running correctly. And it configures Unicorn. So I run my play against my web servers, and I see that everything's ran successfully, and there's been a lot of changes. You'll also see here that my play has taken a long time. 13 minutes has elapsed in configuring this instance. All of my other instances were around a minute. The thing that's taking the longest here is building Ruby, which makes sense. Building Ruby is a pretty consuming process. So for me, building Ruby takes about 12 minutes. Fortunately, Ansible configures all of these instances in parallel, so I'm not waiting 24 minutes for everything to come up in serial. But 12 minutes is still way too long, and we can do better. We do better by throwing Packer into the mix. I can build a base image with most of my dependencies already installed for my web project, and then use that base image in the future when I create my instance resources. I'm using Packer in local mode here, which means instead of running Ansible on my personal machine, it's being ran on the remote host. Newer versions of Packer actually support running Ansible in the traditional method, but this works for me. If running it the other way works for you, go for it. So after setting up a few variables, I install Ansible on the remote machine, and then I call the particular playbook that I need to install the base image. This is a new playbook that only is concerned with installing those dependencies. It doesn't do things like copying over the project code. So since I have two different configurations now, or two different plays that are covering the same things, I can have my base image configuration, which installs all those dependencies. And then I can have my actual deploy configuration, my deploy play, which brings over additional dependencies, installs the project itself. And you can see on the very top line that I've added an include line. What this does is includes the other playbook and runs that first, so that when I'm doing a deploy, I have the additional assurance of knowing that everything that I wanted to be built in the image is actually there. Since Ansible is going through and making sure that everything is in the state that's expected, most of these tasks will just skip. But in the case where if you wanted to, let's say, change your Ruby version and test that out, but you didn't want to bother building a brand new base image, you could edit that in the code, run a normal deploy, and it would take care of that for you. Obviously, in that case, you would lose the speed benefit that you get by baking these into the base image, but you're at least not stuck. So I cd into the Packer directory. I called the Packer build command with a few variables that I need. And what Packer does is creates a temporary resource in Google Cloud, then runs those Ansible tasks on that resource and stores that image that's created at the end. Now that I have a new base image, I can go back to my web server module and edit the disk image that I associate that instance with. So before I was using CentOS, now I can say use web base instead, which is the image that I've created myself. I'll rerun my make create command. Terraform will notice that there's been changes in the base image for the two web server instances, and it will destroy those and create new ones with the proper base image. If this were an actual production environment, you would want to do this a little differently. You might want to push up a maintenance page, or you would probably want to make this a rolling deploy, but for this sample case, it works fine. Then we go into Ansible and run all of the same commands that we've ran previously. And you can see that the time to build has reduced dramatically. We went from 13 minutes down to 4 minutes simply because we're no longer building Ruby. There's still more speed gains to be got here, but this is a pretty good optimization at this point. So now we have a functioning environment, and I was able to build all of it without having to SSH into a machine and configure things by hand. If you're anything like us and you had a bunch of unique snowflakes in your environment where everyone has to go in and edit the Nginx config by hand, introducing a pipeline like this can save you a lot of heartache. So now it's time to ship. With projects like this, you have to set a clear stopping point for yourself in the beginning. Otherwise, you can keep working on this forever. We've already identified a few optimizations that could be made, and there's plenty more. But until you ship, you're not actually adding any business to your company. The product isn't getting any better. Your users aren't seeing the benefit. So ship out what you have. That's not to say that there isn't more that I want to do or that could be done. The first thing is probably immutable deploys. Using a tool like Docker or even just a more verbose setup for Packer, I can have immutable deploys. If you saw Vic's talk earlier, there's additional challenges there, which is why we avoided it. From the point where we started to the point where we wanted to end up, attempting to introduce immutable deploys just seemed like too much work for now, and we need to move. So in the future, we'll come back and see how we can integrate this into our system. There's also an automated build system. Right now, I have that Makefile, and I still have to go in and run that Makefile, run make create to update things. That's obviously not ideal. And so in the future, we'd like to introduce some sort of automated pipelining tool. Maybe it's Jenkins, maybe it's Atlas with something else, who knows. And finally, a sandbox staging environment. If any of you have ever used Vagrant before, you know that there's a handy feature called Vagrant Share, where you can create a share a URL to your particular local instance with anyone on your team, and manipulate that instance. We want to take that same sort of idea where everyone is working in isolation and copy it into our staging environment, where now you make a staging share request. It creates a new instance using the exact same plays and Terraform plans that it used to create production, but isolated just for you. And you can share that with anyone else on the team, build and destroy all you want without having to request additional staging instances from anyone. If you want to read through the code, it's all been uploaded to GitHub. You'll find all of the Terraform, Ansible, and Packer files needed that I've shown you today. And that's all. Again, my name is Casey Lang. If you have any questions, I'll be here after the conference, and you're welcome to come up and talk to me. I'm new to this, just like a lot of people, so I'm happy to hear more. Thank you.